My name is Xavier Gordon, and I'm the president of Xergy Energy. We are an energy transition solutions company based in Toronto, Ontario, Canada, with a regional office in Kingston, Jamaica. The goal of this video is to help the audience understand how battery electric vehicles, EVs, are recharged. We will make comparisons to internal combustion engine vehicles and illustrate the most common ways to recharge an EV. Individual markets may vary slightly, especially when it comes to plug standards. Let's first start by recapping the fueling experience for an internal combustion engine. First, you drive to the gas station, where you pump a certain volume of fuel into your vehicle's tank and pay for the transaction based on a cost per unit of volume, dollar per liter or dollar per gallon. It's usually done in under 5 minutes. Then, you use your vehicle until you approach a lower limit of fuel. At that point, you then drive back to the gas station. Stations are usually located along major roadways served by numerous vendors in a competitive market. Prices may vary daily depending on the retailer and the fuel class being purchased, whether it's regular, premium, or diesel. So let's look at an example of fueling a vehicle in Jamaica. A 2020 BMW 5 Series has a tank size of 68 liters, an estimated fuel economy of 9.5 liters per 100 kilometers. The gas price of fuel in Jamaica for regular in November 2020 is about $132.74. Therefore, that works out to be a cost per kilometer of $12.50. Now, let's look at the recharging process for an electric vehicle. 1. You park it. 2. You plug it in. 3. You walk away. 4. You plug it out. And 5. You drive away. So to compare, EVs are charged using electricity, with their metric being kilowatt hours, just like it would be for your home or business. Recharging can take place anywhere where you have permission to access electricity. The learning part when it comes to EV charging is really the recharge time. Before we get into questions about that process, let's look at the cost to charge a comparable EV to the BMW 5 Series that we talked about earlier. A Tesla Model 3 Standard Range Plus has a battery size of around 50 kilowatt hours. Think of the battery size as something equivalent to that of the tank, how much energy that vehicle stores. That battery, from full to empty, will get you around 450 kilometers of range. The cost of residential electricity in Jamaica at the time of this recording is around $38.60 per kilowatt hour. That means to fully recharge your car, you would need around 1,930 Jamaican dollars. That is $4.30 per kilometer, or roughly 1/3 the cost of a BMW. We can conclude that having the charger in the right spot at the right time can result in the massive energy cost savings that are attributed to an EV. Now that seems simple enough, but for a regular driver it leaves a lot of questions. The first question is, will my parking space allow me to plug it in? It is likely that your parking spot is close to a source of electricity. This means you can plug into the closest outlet, assuming you have permission to do so, or you can plug into an electric vehicle charging station that has already been connected to that electricity source. Having the right connection where you park will significantly increase the convenience of recharging your EV. So let's say you have sorted out having power close to a parking spot. How long do you have to be there? It depends on the car, and it depends on the equipment that is recharging the car. To go from empty to full can vary, from 40 hours to 30 minutes. But remember, most vehicles are parked 90% of the time. The concept of charging while you park is called opportunity charging. Instead of going from empty to full with long durations in between, the EV driver will recharge in small increments. When charging is done from home, this almost always results in leaving home in the morning with a fully charged vehicle. A modern EV in 2020 is usually capable of 250 to 500 kilometers of range. Given these distances, most drivers may only need to plug in once a week. Let's talk about the 3 levels of EV charging and how we can calculate recharge times. Level 1 is usually called portable charging, because you'll use a portable cord that comes with your EV and plug it into any standard outlet. This is the slowest way to recharge an EV. Level 2 is usually called fast charging. It can be done by a heavy-duty powered portable cord, or more commonly, using a fast charging station. It will connect to the grid by way of a higher voltage and higher current circuit installed specifically for its use. This circuit is comparable to that of an electric clothes drying machine. Level 3 is usually referred to as rapid charging. These are heavy-duty charging stations that operate using DC power rather than the AC power that is found on level 1 and level 2 charging infrastructure. They will connect to commercial grade voltage and current circuits that require in-depth installation and experience. These chargers are usually found near highways, busy central districts, airports, and major destinations. Now, recharging depends on both the EV charger as well as the EV itself. Think of the EV as being able to pull power and the charger as being able to push. When an EV is first plugged into a charger, the two devices will communicate with one another to see which of the two is the slowest and then agree to charge at that rate. The recharge rate is usually specified in kilowatts of power. The amount of time needed to recharge a battery will be a function of both that power rating and how much energy the battery needs to be full. One thing to note is that most new EVs will be able to accept level 2 and level 3 charging at different rates. Let's look at an example. Let's assume your vehicle has a 56 kilowatt hour battery and can accept 11 kilowatts at level 2 and 200 kilowatts at level 3. Let's also assume you have a level 1 charger that can push 2 kilowatts of power, a level 2 charger that can push 8 kilowatts, and a level 3 charger that can push 150 kilowatts. In each of these three cases, the charger, not the vehicle, has the lower limit, and therefore we would use those figures to calculate the recharge times. So for a level 1 charger pushing 2 kilowatts, it would take 27 hours to recharge the battery. For a level 2 charger at 8 kilowatts, it would take 7 hours to recharge the battery. And for a level 3 charger pushing 150 kilowatts, it would take 23 minutes to recharge the battery. In addition to EV charging speeds, there are also different plug types, similar to electricity outlets. Just like outlets, different plug types are associated with different countries of origin. In the Caribbean, being a primarily right-hand drive market, most new EVs will either have a European or Japanese plug standard. Okay, after looking at those numbers and plug types, let's go take a look at EV charging in action. Let's start by looking at a level 1 portable EV charger. This mobile connector came with my EV and can be plugged into any standard outlet. Here it is in my garage, with one end in the outlet and the other end plugged into my EV. Let's take a look at how fast the car is charging. So we are pulling approximately 115 volts at 12 amps, or roughly 1.38 kilowatts of power. For this EV, that translates to around 8 kilometers per hour of charging. If my EV is parked at home for 10 hours a day, then I can recharge roughly 80 kilometers of range every night. If my daily commute is less than this, then level 1 charging is suitable for my day-to-day needs. Do note, level 1 charging is not suitable for my daily driving needs. And so, I installed an additional 240 volt circuit in my garage that can give myself level 2 charging speeds on a regular basis. This level 1 travel cord will stay in my EV, so if I'm ever on a long trip to visit family or friends, I can grab a quick charge overnight if I need it. The 240 volt level 2 charger is typical for most EV drivers, but let's visit our office to see level 2 charging in action. This is Xergy's main office charger, or as it is commonly referred to, a quick charger. This is a quick charger for tenants of this building, and as such, runs on intelligent software that can do billing, collect usage data, and grant special access to the charger separate from the public. Let's try using it like a member of the general public. I simply log into my mobile charging application on my phone and request authorization, i.e. pay, to unlock the charging service. I then plug into the car and voila, I'm charging. Note that this charger is billing me for every minute my EV is connected to the charger. Your individual public charging rate may vary by price or may charge you by kilowatt hour. This station is much quicker than a level 1 portable cord. It is pulling 30 amps at 208 volts or approximately 6.24 kilowatts of power and is charging at 40 kilometers per hour. This is around the same speed as my level 2 charger at home. Now, let's visit a rapid charger. We are in Etobicoke, Ontario, checking out Tesla's supercharging network, which can give us rapid recharging speeds even faster than our office charger. It is very rare that I use these stations, but it is very useful for those occasional long trips. I simply walk up to the charger, detach the plug, and connect it to my charging port. Other charging networks may require users to use a mobile application, an RFID card, or tap their credit card to access the charging service. Tesla's mobile app and other networks like the ChargeLab network that is being used in Jamaica allows users to simply plug in and walk away. Public charging allows drivers access to recharging services while on the go, on extended trips, or if they don't have access to private charging at home. Private charging networks are developed and deployed for specific vehicles, whether for a private company, a government fleet like police vehicles, or a public transit agency with electric buses. These fleets will typically have their own chargers reserved for their exclusive use, giving them full control over charging cost, timing, and availability. The development of public and private charging networks go beyond just plugging in, but require the smart deployment of the right hardware and specialized software to help managers get even more value from their fleet by allowing chargers and vehicles to 1. Monetize the use of charging stations to recoup any investments, collect data for analysis and optimization, reduce the strain of electrical consumption to the public utility grid, minimize the number of chargers needed to operate a given fleet, control power flow to multiple vehicles, schedule recharging times throughout the day, maximize EV vehicle fleet availability for deployment, and monitor battery health and usage over time. I hope you've learned a little bit about EV charging in this short introduction video. If you want to learn more about how EVs can impact your bottom line, feel free to reach out to the team by sending us an email at info@xergy.ca. Thanks and take care.